Okay, we got a couple definitions today. One is one-to-one. That means that a function has an inverse. Okay, so now do functions have inverses? Last week we drew an example of a graph. I'm going to kind of put it over in the side here. There's not a lot of space. And we did a parabola, y equals x squared. So last week we talked about how an inverse reflects over the line y equals x. So here's y equals x, that diagonal line. And then we sketched the inverse. So the inverse is actually a sideways parabola. The problem with that sideways parabola is that the sideways parabola is now no longer a function. It doesn't pass the vertical line test. So technically, x squared does not have an inverse. So there's a couple ways we can avoid that. So we can tell right away if something's going to have an inverse. So we do the opposite of the vertical line test. If the inverse doesn't pass the vertical line test, that means the original must not pass a horizontal line test. So a horizontal line test if f of x has an inverse. I know, that's a terrible color. Test if f of x has an inverse. So as long as the function is always increasing, so like x to the third, that would always have an inverse because that always passes the horizontal line test. Or if it's decreasing the whole time, it would have an inverse. So most of the time we can just tell if something's a function just by what we know it looks like. So for number one, I know the square root of x looks like that, right? And then what does the plus one do to the graph? Moves it up one. So would that pass the horizontal line test? Yeah, so this would have an inverse. So it answers the question, is it one-to-one? Yes, because it has an inverse. Now, number two, x to the fourth. That's not one of our parent functions, but any even exponent is going to take the basic shape of a parabola. The higher the exponent, the flatter the bottom gets. So it's just a little bit wider than like regular x squared. But would this be one-to-one? Right? That would not pass the horizontal line test. Now, number three, I know is a parabola. So normally I'd say no, that doesn't pass the horizontal line test. But I know this parabola starts at -3 because it's shifted left 3. This parabola has a constraint with it. This is saying we're only looking at the right side of the parabola. So everything greater than or equal to -3. Just that part. So I can ignore the left side. So if I just look at the right side, would that have an inverse? Yes. So that's how you can kind of cheat and make everything have an inverse. You just restrict the domain. So if you ever see this constraint written here, they're making it so it's possible to have an inverse. Okay, number 4. Let's see. What shape is this graph going to take? Just going to be a straight line, right? Would that pass the horizontal line test? Yeah. Now 5 is where we need our calculator because 5 is not a parent function that we know. So when in doubt, you can always plug it in your calculator. Let's see here. We've got x squared over x squared plus 1. Yes or no? Nope, that does not pass the horizontal line test, so that is a no. Okay, we're gonna skip the steps because we did those Friday, how to solve for an inverse. So tomorrow you guys are gonna have a quiz. We'll go over, I'll give you some examples, but one of the questions is gonna be finding an inverse algebraically. So last week we did this whole process, right? Process is to switch the x and y. That's our first step. And then we solve for y. So I'm going to cross multiply that 2 over first. Then I'm going to divide. Whoops, sorry. I'm going to subtract the 5 first. Ahead of myself. Then I'm going to divide by -3. But remember, we want to write our answer. We don't want to use y. We want to use f of x, bless you. And to show that it's the inverse, we're going to use the inverse symbol. So f inverse of x would be 2x minus 5 over -3. Or you could write -2/3 x plus 5/3. Number 7, let's switch x and y. I'm going to solve, I'm going to add the 4 over. So the only thing I have to do to solve for y is to take a cube root to get rid of that cube. So I'm going to undo that. I'm going to do a cube root of x plus 4. Okay. Couple more. Number 8, let's switch x and y. What would we do first to solve for y? Square both sides, yeah. Add the 3. And then divide by 2. So the inverse, x squared plus 3 over 2. Okay, now the last one, if I were to graph this on my calculator, we did one like this last week. It ends up looking like a semicircle. It is a semicircle. It goes from -2 to 2. So right now I could just say this doesn't have an inverse because that doesn't pass the horizontal line test. But they give us a constraint. They're saying we only want to look at the right side from 0 to 2, not the left side. So the right side would be okay. We're going to find the inverse. So I'm still going to solve it the same way. I'm going to switch my x and y. You're just going to see kind of something weird come up when something's not an inverse. So I'm going to solve. I'm going to square both sides. I'm going to subtract the 4. Then divide by the negative. So y squared equals -x squared plus 4. So here's the weird part. So to solve for y, we still have one more step. We have to undo the square. So I'm going to take the square root of both sides, which normally I'd need a plus or minus. But a plus or minus root, I'm going to draw it up here, look like that, which would not pass the vertical line test. So we only want 1/2. Which half do you think we're going to want? Do you think we're going to want the top half or the bottom half? The top half is the one that reflects this line over y equals x. So I only want y equals the positive square root of -x squared plus 4. So hint would be if you're looking at the positive side of the original function, you want the positive side of the inverse function. So if we were looking at the opposite side, we want the negative square root. So if you got a piece of scrap paper or you've got your a piece of scrap paper, take out something. We're gonna put some what you guys are gonna need for your test. Quiz. Tomorrow's a quiz. Quiz tomorrow. I don't remember what it was. There's 3 things on the quiz tomorrow: parent functions, composition, and inverses. You guys can use your parent function note card. I'll also have it on the board over there because we're gonna leave it up for. We're gonna work on projects the rest of the week here. So you might get a problem like this. I'm just gonna make something up. Y equals -3 times the square root of x plus 9 minus 7. There we have a function. We're going to first decide what the parent function is so we know how to compare it. What would the parent function be of that graph? Square root of x, yeah. So we're going to compare it. So if it's just the square root of x, we've got all these extra numbers in here that are going to do something to the graph. So let's work our way. Let's just go from left to right. What is this negative doing to the graph? Yeah, if you look at our list, it's out in front. It's an x-axis reflection. All right, next is this 3. These ones are always a little trickier. So we're multiplying by the 3. The multiplying ones are these ones over here. Stretches and shrinks. What would 3 out in front do? Vertical stretch. The 3 out in front, 3 is greater than 1. So that's a vertical stretch. And plus 9 underneath the radical. Left 9. And then minus 7 on the outside. Down 7. So just basically decoding what these functions are telling us. So that's a pretty complicated one. That's got one of each in it. So if I had like y equals 1/3 x to the 3rd power, oh, but I'm going to put that inside with the x. What would that 1/3 inside the parentheses with the x do to the graph? Yep, inside. Being multiplied and it's between 0 and 1, so that would be a horizontal stretch. Those are probably the hardest ones to do. Okay, so that's the first type of question. Second type would be composition. In these last week. So I might give you some functions. F of x is 3x minus 7. G of x is 4x squared. Making them up. We're going to find f of, I'm going to write it a weird way, the way that the book sometimes writes that. F of g of 5. So the other way to write this would be f of g of 5. That. So we can do this 2 different ways. We could plug the 5 into the g and then that answer into the f. Or we could plug g into the f and then plug in 5 when we're done. So I'm going to find f of g of x first. So I'm going to take g, plug it into f. So 3 times 4x squared minus 7. Then this 5 at the end, that means we're plugging 5 in, not multiplied by 5. So we're going to plug 5 in for x. And then we're just going to evaluate. You can use your calculator to do all of that. 5 squared is 25, times 4 is 100, times 3 is 300, 300 minus 7 is 293. So again, the other way to do it would be to plug 5 into the G, which gives me 100, and then plug 100 into F. Still gives me 293. Third would be your inverses. We've been working on those the last 2 days, so that should be fresh in your minds. They might give you a function f of x equals 7x minus 2 over 3. So this has a function, it's just a straight line. So I'm going to switch x and y. And we're going to solve for y, so I've got to cross multiply to do that. 3x equals 7y minus 2. I'm going to add the 2. And then divide by the 7. So the inverse, gotta label it. 3x plus 2 over 7. So you've got homework you're going to work on tonight. It's due tomorrow. We will go over it before we take the quiz. So this will be good for review tomorrow too. So for the first part of the homework, you're just going to say yes or no if they have inverses or not. You might need to graph it if you don't know what it looks like, but you should know all the dates. And then 5 through 10, you're actually going to find the inverse. So switch x and y and solve for y. 7 and 9 are the tricky ones. When you switch x and y, you're going to want to cross multiply first. Definitely trickier.